Number 14 says, fill in the table below using your conversion ratios for degrees to radians. A reminder, to go from degrees to radians, we want to multiply by pi over 180. We also want to keep our fraction in fully simplified form with pi in it. To go from radians to degrees, we want to multiply by 180 over pi. And it's okay if your degrees are decimals. Okay, let's start with the degrees. So we'll start with 255 degrees. I'll do my work to the left over here. 255 times pi over 180. Let's see, we'll reduce this by figuring out what the greatest common factor would be here between these two numbers. 5 goes into both 255 and 180. So let's see, 180 divided by 5 would be 36. 255 divided by 5 would be 51. So this reduces to 51 pi over 36, which can be reduced further because 3 goes into 36 and 51. 3 goes into 36 12 times. 3 goes into 51 17 times. So our fully reduced answer here would be 17 pi over 12. Okay, now let's do 720 degrees. 720 times pi over 180. 180 actually goes into both of these numbers. 180 goes into itself once, and 180 goes into 720 4 times. So that becomes 4 times pi over 1, which is just 4 pi. Okay, let's do negative 20 degrees. Negative 20 times pi over 180. 20 goes into both of these numbers. 20 goes into 180 9 times. 20 goes into negative 20 negative 1 times. Negative 1 times pi over 9 is just negative pi over 9. Okay, last but not least, 36 degrees. 36 times pi over 180. 36 goes into 185 times, and it goes into itself once. Again, if you're maybe not jumping to the greatest common factor, you can start small. You can start with dividing the 36 and the 180 by 3 and then work your way from there. But our fully reduced answer here would be pi over 5. Okay, now let's convert from radians to degrees. I'll do that up top here. 11 pi over 4, we're going to take that and multiply it by 180 over pi. Okay, your pi's cancel out. The 4 and the 180 could be reduced. 4 goes into 4 once, and 4 goes into 180 45 times. So this is now 11 times 45, which is 495 degrees. Okay, and I'm gonna erase this over here just to have some more room to work. The last conversion we're gonna do is 9 pi over 10. 9 pi over 10 times 180 over pi. Again, the pi's cancel out. 10 goes into 10 once. 10 goes into 180 18 times. 9 times 18 would be 162. Okay, that's it for number 14. Number 15 says, find the angles that make the following equations true. So A is sine theta equals negative root 3 over 2. B is cosine theta equals root 2 over 2. We can use our unit circle for this part. I want to remind you that on the unit circle, every single point is written as cosine theta comma sine theta, where theta is just the angle of rotation from 0. So for example, if I zoom into pi over 3, these two values right here are just cosine pi over 3 and sine pi over 3. How does this help me find the answers to this problem? Well, let's look at the angles on the unit circle where the sine value is negative root 3 over 2. In other words, let's look at the points on the unit circle where the y-coordinate is negative root 3 over 2. And those angles will be our solutions here. So let's see, negative root 3 over 2 moving around the unit circle. We see that here and here. Again, the sine of that angle is your y-coordinate, and so the two angles that we're looking for here are 4 pi over 3 and 5 pi over 3. The sine of 4 pi over 3 is negative root 3 over 2, and same deal for the sine of 5 pi over 3. So those are our two answers, 4 pi over 3, 5 pi over 3. If you want to write your answers in degrees, 240 degrees and 300 degrees, that's fine. I'm going to write it in radians. So theta equals 4 pi over 3 or 5 pi over 3. And then we'll do the same thing for B. Where do we see, in this case, because it's cosine that we're dealing with, where do we see x coordinates of root 2 over 2? We see that here and here. Those two x coordinates. The cosine of 7 pi over 4 is root 2 over 2, and the cosine of pi over 4 is root 2 over 2. And so our solutions for part B are pi over 4 and 7 pi over 4. Again, you can write your answer in degrees if you want to. Okay, last problem on this slide, number 16. Find the exact values of the following. This is kind of similar except the opposite. We're going to go to the angle identified here, and then depending on whether we're asked to find sine or cosine, we're going to look for the x or the y coordinate. So the cosine of 2 pi over 3 means that we're going to find 2 pi over 3 on the unit circle. That is right here. The cosine of 2 pi over 3 would be the x coordinate. So negative 1/2. That's it for A, -1/2. For B, sine of 11 pi over 3. 11 pi over 3 is not here. Okay, what we can do here, since it's not listed, is think about what it means for us to go past 2 pi on the unit circle. Let me draw a diagram here. Actually, let me go back to the unit circle and erase what we've got so far. Okay, on this unit circle, we've got pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, and then 6 pi over 3 is just 2 pi. If we're going all the way out to 11 pi over 3, that just means keep going, keep rotating. This would be 7 pi over 3, right? If this is 6 pi over 3, that's 7 pi over 3. This is 8 pi over 3, 9 pi over 3, 10 pi over 3, 11 pi over 3. So again, 11 pi over 3 was a radian that was too big to see on the unit circle because it was beyond just one full rotation, but we can keep going. 11 pi over 3 is right here, and we were looking for the sine value. So at 11 pi over 3, which is technically just 5 pi over 3, that sine value, that y coordinate, is -√3 over 2. Okay, last one, cosine of -3 pi over 4. Here's another one that requires us to think about the unit circle beyond just looking at it. -3 pi over 4 doesn't show up on the unit circle because it's negative. And what negative angles mean is to just go clockwise around the unit circle instead of counterclockwise. So you'll see that 3 pi over 4 is right here. -3 pi over 4 would be the same rotation, just the opposite way. Notice that that's the same distance rotated around the unit circle, just in the opposite direction. So the cosine of -3 pi over 4 is technically the same as the cosine of 5 pi over 4, since that's where we're landing at. And at 5 pi over 4, it looks like our x-coordinate is -√2 over 2. And so there's our answer for that. Please email me if you have further questions about these specific problems.